Welcome back. I'm Corey, and we're about to get started on day 5 of Advent of Code in Rust. If you missed the previous days, check out my playlist up top for all my solutions, and don't forget to like and subscribe for more videos. Let's get started. Okay, let's go ahead and get started on day 5 here. Day 5 is supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacked of marked crates, but because the needed supplies are buried under many other crates, the crates need to be arranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will arrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of the stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and arrangement procedure, your puzzle input, for example. Okay, so in this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is the bottom, crate N is on top. Stack 2 contains 3 crates, from bottom to top. They are crates M, C, D. Finally, stack 3 contains a single crate P. Now the arrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, the crate is moved from stack 1 to stack 2, resulting in this configuration. So the D comes from there to there. In the second step, 3 crates are moved from stack 1 to 3. Crates are moved one at a time, so the first crate to be moved D ends up below the second and third crate. So basically we just repeat. When we move 3, we move D, then we move N, then we move Z, so Z's on top. Then both crates are moved from 2 to stack 1. Again, because crates are moved one at a time, crate C ends up below. So then we do that. Finally, one crate is moved from 1 to 2. The elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. So you should combine these together and give the elves the message CMZ. Okay, after the arrangement procedure completes, what crate ends up on top of each stack? Okay, so I think the biggest thing here is gonna be parsing this part of the input. This part is the arrangement part, and this one should be easy enough to parse. We just need these numbers out. But this with the stacks is gonna be a bit more interesting, because what we've liked doing so far is parsing things line by line and getting the things out. But this is not line by line. This is like there's spaces here and stuff like that. So we're definitely gonna need to do something a bit different here, I think. With the monospace, we seem to have 3 things and then a space, and then 3 things and then a space. So I think maybe how I'm thinking about it is we can go into characters and chunk them into sections of 4. And then from the sections of 4, we will do something. Okay. Let's get started, and I think the parsing is going to be most of this puzzle here. Let's do a cargo new. We're doing a library like we've been doing. O5. And what is this? Supply stacks. And we're going to name it supply stack. We will add it to our cargo workspace. Okay, CD to O5, cargo test. Awesome. Let's go into 5 here. And let's get started. Okay, so the first thing that we want to do is, I guess we could, let's copy over our input. So let's add a new file, for example, input. And let's copy it. Okay. There we go. And let's do some parsing here. Okay, so the first thing that I think I want to do is separate these out. But I guess let's just go ahead and get an example. We'll do our example input part 1. Let input equal include string example.input. Let the answer equal part 1 of input. Assert. Oh, and actually, this is not going to be an integer. For the first time, our answer is going to be a string. CMZ. Assert equal that our answer is that. And we don't have a part 1 function. It takes in an input, and it actually is going to output a string, so that we can match it on CMZ. This is the first time we're not returning an integer, but that's okay. Fun to do something new. Okay. So let's see what we want to do for parsing. Do I want to make a struct for everything? Do I want 2 structs? So let's see, I have some stacks and I have some rearrangements. So let's do a, struct for, I don't know, just everything. It's like the struct is gonna be crane yard or something, because we have a crane operator. So let's do a crane yard. It has some stacks. It has, let's just do a vec. I might want that to be something different, but let's have it be a vec of characters. Those are gonna be our stacks. And then we have some rearrangements, which is gonna be a vec of rearrangements. And then I said, let's make our struct for rearrangements. It's gonna have a from and a to and a count. From a usize to a usize. So usize is just gonna be our stack counter. It's just gonna be the index into our stacks array. And then we have a count. Also make it a usize here. We'll just be consistent, make everything usize. In Rust, usize is going to be a size. It's an unsigned integer type, and it matches the size of how many bytes it takes to reference any location in memory. So in a typical 32-bit application, it's 4 bytes, and on a 64-bit target, it's 8 bytes. So this is the U64 likely for me. But we'll just match the usize here. And okay, so now we want to write an impl for our crane yard. Impl crane yard function parse takes an input and returns a self. Okay, so in crane yard we have 2 things. We have stacks and arrangements. So to do that, first we do let a split equal input dot split on new line, and then let stacks equal split dot next dot unwrap, and let rearrangements equal split dot next dot unwrap. And then let's do a debug for stacks, comma rearrangements, and let's return a to do. This needs to be mutable. There we go. Okay, so now we can actually do, oops. Let the yard equal crane yard dot parse, not a dot, we don't have an actual object, it parses input, and there we go. Okay, now if we run this, it's still not gonna pass, obviously. Should error on a to-do and not yet implemented. And okay, so we do have our stacks. They look like they are separated from our rearrangements, so that is good. And stacks are actually one indexed, so we will have to deal with that. That's just a good call out. And I wonder if they're in order all the time. But they are for me here. But that's interesting. It's a good thing to think about here. Okay. Let's go ahead and get started. So now I want to parse the stacks and the rearrangements. The rearrangements are going to be the easy one here. And I probably just want to do these with a regex. So let's work on that, because I think these are going to be easier to parse out. So let's write a test that tests this parsing. So let's do a test function test parsing arrangements, rearrangements. Let input, nope, input, let's just copy the line. Let yard equal a crane yard parse out our input, and then assert equals that yard dot rearrangements dot length is 4. And this is a vex, so then I can do something. Nope, let's do it after that. Assert equal yard dot rearrangements at 0 equals a rearrangement from 2 to 1, from 2 to 1, and a count of 1. Reference, probably. Type, oh, we have to actually tell it that rearrangements can be equal to each other. Let's derive our partial equals. Now what are you mad about? Rearrangements doesn't implement debug. Assert equals wants to be able to debug those out, so let's make it implement debug. Expected struct found. Oh, okay, so this one was just that I had tried guessing at an error too early. Awesome. Okay, so now we can check that our arrangement, that first one's right. Let's just check the next one. 1 to 3 and 3. From 1 to 3, there are 3 of them. That's the first one, and I guess let's just do all of them. We might as well. We've already done the first 2. 2 to 1 and 2. From 2 to 1, there are 2 of them, and one last one for the end. That actually is that'll be that. Oops, replace 3. 1 to 2 and 1. From 1 to 2 and 1. Okay. Okay. So that's definitely not gonna pass because we don't even finish parsing. I think we currently blow up on parsing. Okay, we also have to deal with stacks. I could just comment this out for now so that I could actually return something for arrangements. I will probably do that. Okay, so then now I want to parse each rearrangement line, and I do think I'm gonna want an but let's write a parse method for here. There we go. Impl rearrangements. This one's our easy one. Well, more like the other ones where we just can write a parse method and it works off the lines, which we like that idea for sure. And then this returns a rearrangements. Okay, so this takes, we have a regex here. So we're actually we're going to add a crate here. We haven't done that yet. We're going to cargo add the regex crate so that we can do some regex matching here. Let r equals from the regex crate. Let's get a regex. And what do we want our regex to say? We want it to say something a lot like this. This is our example. And we want a thing here. This is a captured group for some numbers. Same thing there, and same thing there. And then when you do this, we're going to unwrap it. We're going to say that we actually get, but we know this is a valid regex, and it'll parse. And then we can do r dot captures captures iter. Yeah, let's do captures iter of our input. And then I do know from this that I want to skip the first one because the first capture is going to be the whole match. It's going to be the whole line. So I don't want that one, and then I want these ones, 1, 2, 3. So actually no, let's just do captures. I don't want iter. Because there's only 3 of these things here. It's count from 2, and I know that. So let's just do let captures equals this, and we're gonna unwrap it. We're gonna say expect each rearrangement line should have this format. If they don't, then we're just gonna panic here. Okay, so now we have our captures, so we can do, I think we could even just do a self now, and we could do count equals captures dot get the first capture. That's probably gonna give me something I want to unwrap. I think this is gonna give me found a regex match. Okay. Can I then do 2 string on this? Can I 2 string this? 2 string exists, but its trait bounds were not satisfied. Okay, so match doesn't implement that. Okay, so regex match rust. Let's look at the docs here really quick. Okay, so I was calling captures, which gave me a captures. And from captures, I called get, which gave me this match, and match has an as string. There we go. That's what I'm looking for. As string, and then I can parse that string to a usize and unwrap that error. And after all of that, we should have a count that is the right thing. And then from is the next one, captures dot get 2 dot unwrap dot as string dot parse dot unwrap. And then 2 is captures dot get 3 dot unwrap dot as string dot parse dot unwrap. Okay, so we got that implemented. We got the parse. So now when we actually want to, yeah, okay, so now I can do self here, rearrangements equals rearrangements this dot lines dot map rearrangements parse dot collect. None of that. Okay, no to do after it. Awesome. Okay, so rearrangements now is actually going to be parsed out, and I think we should pass this parsing test. Ooh, let's see. Each arrangement line should have this format. Okay, so we got one that did not have that format. Awesome. Let's do this first thing, which might just be trim it. And let's try that again. I'm not positive if that was the issue, but it is always a good first thing to try, I feel like. Nope. Okay, so now we want to go to our rearrangement parse method. And I think what we want to do here is just debug out the input so that we can see what we are dealing with. And yeah, let's go from there. Run test. Our input is move 1 from 2 to 1, and it just doesn't think that that matches our regex. Okay. And that's the first one, right? Move 1 to 1. Okay, let's go ahead and take a look. That's what I did. I made this big. Okay. So our regex is move that from that to that. Okay, that looks reasonable to me. Do I have these in the wrong direction? No, because now slash D doesn't know. Unknown escape character D. But is that just because it doesn't know? Does it not have digit stuff? I think it should be able to do digit. Yeah. Do slash D and then the number. So that's what I want there. Slash D. Why is that not valid? If that's valid, do I need to do this R thing for the string? Yeah, there we go. I need to tell it that it's a, like, special regexy type string. And I flipped my slashes to be that way. Okay, is this a better... There we go. Okay, now they are parsing nicely. I just had my regex wrong there. Okay, so I don't need to debug that. We are parsing our rearrangements nicely, but now we have to do the actual fun part here and parse the stacks. Probably didn't need to copy that whole shebang, but I did. Test parsing stacks now. So now we got our stacks. We should have 3 stacks. And let's just say we just have 3 stacks at the moment. It actually doesn't like this because it doesn't know that it has stacks. There we go. Now it has stacks again. And then we can do assert equals yard dot stacks at 0 is a vec of what's in our first stack in this example. Z and then N. So I think I want the last thing to be the top, so I want to go ZN. Okay. And then in stack, the second one, we want MCD, MCD, and then P in our last one here. Okay, what are you all mad about? Can't compare care with a vec of characters. Okay, so I think my type's wrong for this. This is a vec of vecs. Because I want and I can do this though, type stack equals a vec of characters. And so this becomes a vec of stack. This is just how we can like type alias, so vec of car, we're not really making a new type here, we're just referring to that as stack throughout this code. And that should make this happier. Okay, this shouldn't pass though when I run it because I'm not parsing my stacks correctly at all. And I'm actually erroring. I don't even have stacks up here where I want to use it. So craneyard.parse, it doesn't do anything with stacks yet. Okay, so now for the fun part here. We gotta figure out how to parse this. So so I think we want to grab this bottom line. I think this bottom line can tell us how many stacks we're gonna have. And then from there, we can figure out what to do. Okay, so stacks. So then let's make a new variable here. Let stacks equal stacks dot lines dot collect. This wants to be a vec of strings. Okay, so now we have a vec of strings, and we have stack IDs is stacks.last dot unwrap. We know there's gonna be something here. And then we do let stack count equal stack IDs dot characters, and then we're gonna do the chunk characters stack IDs. So then let's do let stack characters equals stack IDs dot characters dot collect. This wants to be a vec of something. Actually, I know what it wants to be. I want it to be a vec of characters. That's plural. And then this can be stack characters dot chunks of 4 things. And then I want the length, because I just want to know how many there are. And then let's just debug out the stack count. This is just to see what we get out of it here. And then stacks is to do, we just want to be able to compile you so that I can run this. Okay. Let's try that out. Not yet implemented, but stack count is 3. Okay, so that at least parsed this one correctly. So we're gonna hope that it continues to work, but I think that process seems like it should. Okay, so we know how many stacks we have. And so do I want to go from the bottom up? Yeah, okay, so let's do that. So now I know what stack count is, so I can do let immutable stacks equal a vec of vecs, and I want stack count of them. Type annotations needed. How about we just do that? Awesome. Okay, so stacks is a vec of stacks. And we know that it has the right length of stack count. Okay, so now what do I want to do? Let bottom up stacks equal stack. Actually, this last, can I make this like a pop? Can I like just get rid of the last one? I can. And then I want to reverse it. Except reverse doesn't. Yeah, okay, so. Wait. Oh, reverse. No, reverse does the mutable thing. Okay, it's just mad at me for, yeah, okay, got it. Gotta be mutable for this. And then I'm gonna just do stacks.reverse here. Okay, and then for s in stacks. Okay, so now we're gonna be parsing from the bottom up. So the first one should be, so s is our string. Let's see, let's characters equal s dot characters dot collect. This is a vec of characters. Oh, no method. Okay. Stacks. Wait a second. Stacks here. Oh. Okay. Let two parse stacks. There we go. So this then becomes, oh, that didn't, two parse stacks. Okay, there we go. Oh, it's just 2 parse. That's fine too. Okay, so then this is in my 2 parse dot enumerate uh dot 2 parse is a vec, so dot iter dot enumerate. And then it's oops for I think it's I can't type. So when you do enumerate, you end up getting a tuple back, and I think it's yeah, index and then the thing. So this is right. So index is into our stack. So let stack equal stacks at I. So this will index us into our stack. This is not right at all. This is the height of the stack. I don't need this. Okay. Because what we have here is one of these things. So I need to chunk it into the right number of characters here. So that's why we have characters here. Okay, so then for C in pairs dot chunks of 4. So in chunks of 4, we can go through this loop here. Then this is where we want our I. This is where we need to know what stack we're in. Enumerate. Okay, so we have stacks at I dot push C. No. Close though. This is a chunk, not a character. Let's just rename that to chunk. If chunk dot trim equals an empty string. Next. Continue. No trim. Oh, okay. So this is an array of characters. Okay. So if chunk equals space, 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 comma, space. The chunk is empty. We're done. Oh, these ones all need to be chain surrounding dot dot. These are characters, not strings. Actually, what I guess I could write this as is that 4 times. So if the chunk is an empty string, then we do that. And then if it's not an empty string, it's going to be the second thing. So C at 1 is going to be the second character out of chunk. Okay. I think that like could parse correctly. Nope. That's fine. I guess I would have been surprised if it did. Okay, so we didn't get the D on top of Z and D. Z, oh wait. Left, right. Oh, okay, so it added a Z on top that does not exist. Okay, so the D got like shifted over and it became on top of the ZN instead of being here. Okay, so how did that happen? So in our this here, I guess I just want to debug out characters here and just see what we get. At least seems helpful. So at some point we got, yeah, these ones are already trimmed. Why are they already trimmed? Yeah, 1, 2, 3, 4, 5, 6, 7. Yeah, there's only 7 things in this line. Why is this one so much shorter than the rest of them? Oh, because I called a trim somewhere that I don't want actually right now. Because now that's actually going to strip those spaces from the beginning that I cared about. Nice. Okay, that's fine though. Let's see if it's different this time. Oh, okay. Um, we got some spaces in here that I didn't expect to get. So the P line in chunks of four. Oh, okay. If I think I know what I want to do here. We want to go to the next one. If chunk dot length is less than 4, or if chunks are all equal to empty strings. Oh, okay, so now we get nothing in P. Ah. It's actually just going to be less than 3 because I don't care about the space at the end. The space at the end is is pretty valid. So this one's not my best parsing. Maybe we'll come back and try to parse it a little bit better if we get a solution, but for now it'll be okay. Um, okay, so left, now the spaces are back. Great. Um, what if I say that it doesn't start with a open bracket? If chunk at 0 does not equal a open bracket. If the first chunk's not an open bracket, we're skipping it. Where did it actually fail? Oh, passed. Passed. Cool. It didn't fail. Awesome. Okay. That finally got it parsing correctly, at least. And so the last thing here is we actually have to do the part 1, which we haven't done at all yet. Okay, so we have our yard. And then for our in yard dot rearrangements, this needs to be mutable because we're about to do things to it. For I in 0 dot dot r dot count, we got to do this a certain number of times. Let from equal yard dot stacks at r dot from. Let 2 equal yard dot stacks at r dot 2. And then 2 dot push from dot pop. And when we pop it, we're going to unwrap it because we're going to say we always know there's going to be something, and then we will push it. Everything is very upset with us. What is up here? Can't move because it doesn't implement copy. Yep. Reference to a thing. Reference to a thing. Mutable. Mutable. Actually, so I think what I want here is dot like get. What if I just do stacks? A mutable ref. Is that one place where I can do that? Now. Mutable reference. A variable does not need to be mutable, but I want to try to mutate you. Okay, so I think what I want to do here is I don't want to do it this way. I think I want to do dot get mutable from r dot from. And what does it return? It returns an option. Yeah, so we unwrap this now. Yeah. Yard dot stacks dot get mutable r dot 2 dot unwrap. Can't borrow stacks as mutable more than, oh yeah, okay. Okay. Let from C equal from dot pop dot unwrap. So let's change this a bit. We're gonna put this in a block here. The reason for that is now this from will go out of scope, and I can borrow this as mutable again. So just changing up the order of this a little bit. That should be better. You should... Oh. I was gonna say, you should be a character type. We don't need this variable, so let's just underscore it. That'll make this happy. Oh, it doesn't want parentheses. Oops. No, I just want to drop the surrounding parentheses from you. You don't need to be mutable. Why don't you need to be mutable? Oh, because it's a reference to a mutable. I'm not changing the reference. I'm going through that. Okay. And then what is the answer here? We want the top things of all the stacks, right? Which is just going through them and yard dot stats dot iter dot map s dot pop dot unwrap dot collect switch string stacks iter mute. Awesome. Okay, so now we take their stacks and we just pop the last thing off of them and collect it as a string, and maybe that'll work. Shucks, would have been really cool if it did. Oh, yeah. All our indexing is off by 1. From -1 and to -1. Should I just do this when we parse? I kind of want to do this when we parse. So when we parse a rearrangement, our from is actually going to be -1 and our to is going to be -1. Oh man, now it doesn't know what to parse into. That's unfortunate. Okay. How's that? Passed. Awesome. Okay. So let's find some debugs and remove them. Where's another one? Awesome. Okay. And now if I go to my terminal and do cargo test. Oh, 2 failed, 2 passed. Oh, okay. So I'm failing things now, but, oh, okay. That's reasonable. This one, all of these are wrong now because it's from, these ones all need to go down 1, 1 to 0, 0 to 2, oops, 1 to 0, 0 to 1, cargo test, all passed. There we go. Okay. That makes sense. Okay, so we got part 1 with the example. Let's get my input here. My input. And let's see, did we get part 1 solved? We will find out shortly. Okay. My input part 1. My input, it is not going to equal CMZ, but that's okay. QP. Oh, okay, this is going to be where I'm going to actually want to copy this. So echo Q, P, J, P, L, M, N, N, R to PV copy. I can't copy and paste out of my VS Code terminal very well at the moment, so we are just going to work around that really quickly. Yes, there we go. Part 1 is done. Day 5, part 1. Yeah, that parsing was definitely the trickiest of any of the parsings we've done, but it seems like we got it right. Awesome. Okay, and now let's go to part 2. Oh, actually, I guess the last thing that we want to do here is make it so this actually passes. I think I keep getting rid of a thing at the end. Yeah, okay, there's an R at the end that I would like to preserve. There we go. Okay. Cargo test. Okay, now we are doing good. GCA amend, no edits, because I just want to put it with the last one. Perfect. Awesome. Okay, now we are ready to go to part 2. As you watch the cane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't crate mover 9000, it's 9001. 9001 is notable with many new and exciting features. Air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Moving a single crate from 2 to 1 behaves the same. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order, resulting in this configuration. So now you can just drag and drop 3 whole things to the next bucket. And so now we just want to see what the rearrangement looks like with the crate mover 9000. Okay, we can do that. So part 1, let's close you for now. Actually, let's get a test set up. So example input part 2. We're going to look at the example input and part 2, and what do we expect it? MCD. MCD, okay. And now let's go to part 1 so that I can implement a part 2. Okay, and I think a lot of this is going to be the same. The only difference is going to be this moving, where to move... Okay, so if we want to keep things in the same order, I think what I want to do is I'm just going to make a temporary vec, like a holding ground, I don't know. Which is an empty vec, a mutable empty vec, and every time we go in here, instead of pushing it to the end of this, we're going to do holding ground dot prepend. Do I have a like a push to the front or something method? And actually no, here's what I want. I can push it, and then we're gonna reverse the thing at the end. That's the easier way to do it. What is it? It's from character. Okay, so we just are gonna do that, and then we're gonna do holding ground dot reverse, and then we're gonna do two dot append holding ground. Found a mutable reference. And I think that's all we need to do. We do the holding ground, we pick them off, we push them to the end. So when we push to the end, this will be where we actually, yeah, D and Z. So we're going to push D, we're going to push N on top, then we're going to push Z on top, and then we're going to reverse it. And then we're going to append that with D. I think that's right. So our part 2 example, love it, perfect, passed on our first try. Let's get part 2, my input. Example, my input for part 2, my input. It's not going to be MCD, but that's okay. And what do we have here? Oh, I'm going to do it this way. Let's make this bigger. Echo B Q D N W J P V J. PB copy. And let's see. There we go. Part 2, all done. And that is going to wrap up day 5 of Advent of Code. If you liked this video, please give it a like and subscribe to my channel to get notified when all of the rest come out. Day 6 will be coming at you real soon. Thanks for joining me. Bye.